Hi, this is Dr. Srikat Member. In our previous lectures of refraction of light, we have discussed about the definition, what is refraction, what are the physical causes for refraction, natural phenomena like rainbows, etc. Now, this chapter, refraction of light, falls under Unit 4 of light in Diploma syllabus. Learning objective is to identify the angle of incidence and the angle of refraction, also be able to relate the direction which light bends towards or away from the normal if the given the relative speed of light in the two medium. Today we will come to the part of refractive index. Last day already we have discussed this one in our last lecture. If you follow the previous video, you can see what is refractive index. We will just recapitulate from that part. We'll move towards the next course content of this unit. Refractive index means ratio of speed of light in vacuum to the speed of light in medium. If we represent refractive index as eta, then speed of vacuum is c, and speed of light in vacuum is c, and speed of light in medium is v. So this is a refractive index. So it is a unitless quantity. Actually, both are the velocity of light. The units will cancel out. So refractive index itself is a unitless quantity. Now, different mediums having different refractive indices. We have considered refractive index in vacuum is 1, air is 1.0003, carbon dioxide is 1.0005, ice is 1.31, pure water 1.33, ethyl alcohol 1.36, quartz is 1.46, vegetable 1.47, and so on. Already we have discussed the refractive index more is the medium is optically denser. Suppose vacuum is 1, quartz is 1.46. So quartz is optically denser than vacuum. Or pure water is 1.33, quartz is 1.46. So 1.46 is optically denser than water. Again, water is optically rarer than quartz. So this is the list of different materials or different chemicals whose refractive indices are listed here. Let us go to some example for numerical problems. Suppose the problem states that the speed of light in a sample of glass is 1.91 into 10 to the power 8 meter per second. The speed of light in a vacuum is 3 into 10 to the power 8 meter per second. What is the refractive index of this glass? So solve using graph. Recall the graph. Given the list of information to you using symbols and numbers, include units. What are the requirements? List the items that needs to be solved. Use symbols. Analysis. Write mathematical equations that will be used. Solution. Replace the equation with values listed in the given. Solve the equation. Phrase, write the answer to the question in the form of a sentence. Now, from this problem, first, speed of light in a sample of glass is 1.91 10 to the power 8 meter per second. So you can write V is equal to 1.91, that is velocity of light in medium, 1.91 into 10 to the power 8 meter per second. The speed of light in vacuum, that is C is equal to 3 into 10 to the power 8 meter per second. Now come to the formula. What we have to find out? We have to find out the refractive index of the glass, that is required is N. So analysis is the solution. The formula is N is equal to C by V. So 3, C means 3 into 10 to the power 8 meter per second. V means 1.91 10 to the power 8 meter per second. So refractive index becomes 1.51. So we will write the paraphrase as the refractive index of glass is 1.51. What is the speed of light in water? Another example. This is another example. What is the speed of light in water? Given that water has a refractive index 1.33. So the data that is given, refractive index N is supplied. N is equal to 1.33. Speed of light in vacuum, this is general convention 3 into 10 to the power 8 meter per second. So required velocity of light in water. So we are writing it as V. So analysis, N is equal to C by V. Therefore, V is equal to C by N. Solution, V is equal to 3 into 10 to the power 8 meter per second by 1.33. So after dividing this one, we will get 2.26 10 to the power 8 meter per second. So paraphrase, the speed of light in water is 2.26 10 to the power 8 meter per second. Snell's law. This is the laws. This is the well-known law of refraction. The index of refraction can also be calculated using sines of angles in trigonometrical form. Look, this is the air medium, this is water. So light is coming from air to the water. Some part of light is reflected and some part of light is refracted. So angle of incidence is I and angle of refraction is capital R. Its refractive index is, say, air having refractive index is N1 and water having refractive index of N2. So Snell's law states that N1 sine of I is equal to N2 sine of capital R. This is the Snell's law. N1 sine of angle I is equal to N2 sine of angle R. That is the ratio of incidence angle to the refracted angle. It will give you the refractive index. So this I is the angle of incidence, capital R is the angle of refraction. So actually it can be written, if this one is theta 1, this one is theta 2, then N1 sine theta 1 is equal to N2 sine theta 2. And refractive index is sin I by sin R is equal to N2 by N1. Sin I by sin R is equal to N2 by N1, or sin theta 1 by sin theta 2 is equal to N2 by N1. That means the ratio of incidence angle, sine of the incidence angle, the sine of the refracted angle is equal to N2 by N1. Thus, sin theta 1 by sin theta 2 is equal to n2 by n1 is equal to mu. That is the refractive index. Now come to solve a problem. Say light ray moves from water to glass. Water is the rarer, glass is the denser. That is not stated. The angle of incidence in water is 26 degree. Calculate the refracted angle given the index of refraction for water is 1.33 and glass is 2.04. So what are the given values? Theta 1, that means angle of incidence in water is 26 degree. N1, this is the refractive index of the rarer medium, is 1.33. N2 is the refractive index of denser medium, that is here it is glass, 2.04. What we have to find out? The calculate the refracted angle, that means theta 2. Analysis, N1 sin theta 1 is equal to N2 sin theta 2. Therefore, sin theta 2 is equal to N1 sin theta 1 by N2. So solution is sin theta 2 is equal to N1 means 1.33 sin into sin 26 degree by N2 means 2.04. So it becomes 0.497. So using the calculator we can find out theta 2 is equal to sin inverse 0.497 or is equal to 16.6 degree. The paraphrase is the refracted angle of a light ray moving from water to glass is 16.6 degree when the angle of incidence is 26 degree. Given the diagram below, calculate the angle of refraction and draw the refracted ray. Here this medium is glass and its refractive index is 1.33 and this medium is water. Its refractive index is 1.33. Here it is 1.51 N and here it is 1.33. So the denser medium is 1.52, rarer medium is 1.33. Now we have to find out the angle of refraction. So the angle of refraction we know. First we have to draw. Step 1 is normal. Second step, measure the angle of incidence. Third step, calculate the angle of refraction using Snell's law. And fourth step is draw the refracted ray using the angle calculated in step 3. So here we have the data only N1 and N2. If we draw the normal, we will get the incidence angle. So we will get also, then we will get another data, that is sin theta 1. If we get the theta 1, if we draw the normal, theta 1 will be find out. Now putting this into the formula, we can easily calculate the refracted angle theta, and then we can draw the refracted ray also using scale and protector. total internal reflection and the critical angle. This is one picture. There is a tortoise inside the water. Inside the surface of water or a glass block can act like a mirror. This is the picture. Here this is acting like a mirror. Total internal reflection occurs when light reflects off the inside wall of a denser medium, that is higher index of refraction. This is the optical fibers that we can find in different sophisticated elements that is producing lights, and we place it in a drawing room for decoration purpose. When light passes from dense material to less dense medium, light reflects away from the normal. From dense material to the less dense medium, glass to air, it reflects away from the normal. This is we have given in our car example, muddy surface and car example. This is already we have discussed. So this is the recapitulation of our previous lecture. As the angle of incidence increases, the angle of refraction increases. As this is the angle of, this is straight 0 degree moving to the normal. Now if the incidence angle is 20 degree, suppose this one is 27 degree. If the incidence angle increases by 30 degree, then it is 42 degree refracted angle. If incidence angle is 40 degree, then refracted angle is 90 degree. Suppose for a particular angle, the refracted angle is 90 degree. Then this angle, this incidence angle for which the refracted angle is 90 degree, so this incidence angle is known as the critical angle. This incidence angle is known as the critical angle. So critical angle is that incidence angle for which the refracted angle becomes 90 degree. More than this, more than the critical angle, when light incidence in the denser surface, denser medium, then instead of refraction, there will be reflection from the surface between the denser and rarer one. So this is the total internal reflection. Now, at a certain angle, the refracted ray follows a path exactly along the surface of the dense medium. When the angle of refraction, already we have stated, when the angle of refraction is at 90 degree, the incidence angle is known as the critical angle. Critical angle is the angle at which the refracted ray is at 90 degree. Now, more than the critical angle, suppose this is water, this is air. So this light will not be refracted, this will be reflected from the intermediate surface. For water and air, so the critical angle is 48.8 degree. So more than this, that means this is 60 degree. If the light falls at 60 degree in water and air surface, then what will happen? There will be reflection instead of refraction of light from the water surface. Critical angle determines the total internal reflection. If the incidence ray is increased beyond the critical angle, the light is no longer refracted. Instead, it is reflected back inside the medium. This is called total internal reflection. When incidence angle is greater than the critical angle, that means here I is greater than C, there is no refracted rays. All emergent rays are internally reflected. So, as a whole, if we summarize, when light comes from denser medium to the rarer medium, the light moves away from the normal. Now, for a certain incidence angle, if the refracted ray makes an angle of 90 degree, that means refracted ray angle is 90 degree, then this incidence angle for which the refracted angle is 90 degree is known as critical angle. When light is made to fall at a denser medium more than the critical angle, instead of refraction, the light will be refracted back inside the medium. That means light will be reflected back inside the medium. That is, there is no refracted rays. All the emergent rays are internally reflected. This phenomenon is known as total internal reflection. So, this is the picture. A light ray hits the inside face of a semicircular block. This is what is happening. This is a semicircular block. This is polished one. The light ray is hitting this one. It is just internally reflected. Here it is falling. This is then reflected, then going back. Here also, this is the width part. This is width. So this light is coming from this direction and going back to this direction. And this one is totally internally reflected. A light ray hits the inside face of a semicircular block as follows. What will happen as the angle of incidence increases? This is glass. This one is outside this one is air. So this is the incidence ray. So this should go through this direction, but as it is coming from denser medium to the rarer medium, the refracted ray will move away from the normal. So if this one is some part of light is also reflected, that means this one is totally reflected. This is partially reflected. This one is partially refracted. Now again the incidence angle is increases. This is partially reflected and partially refracted. Again it is increases. This is refracted and reflected. For this incidence angle, the refracted ray is making 90 degree with the normal. The refracted ray is making 90 degree with the normal. That means this incidence angle is critical angle. Now here more than the critical angle, when the ray is incidenting on the surface of glass, then there will be no refracted ray. The total light will be reflected from the denser surface. This is known as the total internal reflection.